All right, here we are, part 3, number 1. We're given this function f, and the graph is shown, and they want us to arrange the following in increasing order. So these are just the numbers 0 and 1. There's no relevance to the graph at all. It's just giving us stakes in the ground. So we know we have 0, which is less than 1. We just need to place these other values somewhere on a number line with 0 and 1 also on the number line. First thing they gave us is f prime of 2. So here's x equals 2. F prime will be the slope of the tangent line. So all we know is it's positive. So f prime of 2 we know is greater than 0. So that is helpful. And if I look at this a little bit more closely, say I tried to actually draw a tangent line in, which I'm going to do here at 2. Doesn't want me to do it. Hold up. Let's see if I can get it to go. Perhaps. Nope, not going to happen. So I'm just going to do it by hand, but I'm going to do it better than I did it the first time. Now, the question is, do you think that the slope of that line is greater than or less than 1? And I'm looking at it thinking, well, if it's a slope of 1, it would look like this, right? And I think our slope is less than 1. So I am going to slide f prime of 2 in between 0 and 1. Okay? And then I need to figure out where the other two quantities are going to be placed. So the next one is f prime of 3. Let's take a look at f prime of 3. I'll try to sketch a tangent line. So I'm at 1, 2, 3, and there is my tangent line. So the question is, do you think that is greater than or less than 1? Well, if it were 1, it would look like this. So I would say the slope of our tangent line is now greater than 1. So I'm coming over here and I'm saying that f prime of 3 is greater than 1. The last one that we have is f double prime of 5. F double prime refers to the second derivative, which tells us the concavity of the function. So at 1, 2, 3, 4, 5, the function f is concave down, which means the second derivative will be negative, which means I can place f double prime of 5 right here. Let's go on to number 2. This one says the graph of a function is shown in the figure. And what we want to do is indicate whether f, f prime, and f double prime are positive, negative, or 0. So let's do f first. F is just the y value of the function. At a, f is 0. At b and c, f is positive. And at d, the y value is negative. F prime deals with the slope of the function. Notice that at a, the slope of the function is 0. At b, arguably that is a positive slope. You might argue that it's a 0 slope, but I'm going to go with positive. At C, we have a negative slope, and at D, we clearly have a positive slope. Last, we have f double prime, which deals with the concavity of the function. The function is concave up at A, so the second derivative is positive, concave down at B and C, second derivative negative, concave up at D. And that will do it. And then let's last look at number 4 here. Which of the points labeled has f prime and f double prime non-zero and the same sign? So let's look for f prime positive first. F prime positive will be here, and that's it. The question is f double prime also positive there? And the answer is yes, because the function is concave up. So at B, they're both positive. Now let's look to find where the derivative is negative. F prime will be negative. Looks like it's 0, 0, and 0 at A, C, and D. So negative here at E and negative here at F. So the question is, where is the second derivative also negative, which means the function would be concave down. That happens at E, where the function is concave down, but not at F, where the function is concave up. So I would say at E, both the first and second derivative are negative. Then the last question here is, where at what points are at least 2 of f, f prime, and f double prime equal to 0? Well, let's look first where f is equal to 0, that's A. F prime is also equal to 0 here, so at A we have f and f prime equal to 0. At B, none of the above are equal to 0. At C, f prime is equal to 0, but the function's concave down there, so f double prime is not 0, and the y value is positive, so f is not 0. Let's go on to D. D is an interesting case. The y value is positive, so f is not 0, but we have a horizontal tangent line there, so we know f prime is 0, And do you see how we have an inflection point here because the curve goes from concave up to down? And at inflection points, the second derivative is also 0. Last two cases, on both of these, the first derivative is negative. On both of these, the function is not 0. So right away, we know we have nothing here. If the first derivative and the function are not 0, then two of them can't be 0. So the answers here are just A and D.